Hi students, today we will discuss the derivation for the capacitance of a spherical capacitor. So we know how to find out the capacitance of a capacitor. Capacitor is formed basically by two parallel plates oppositely charged placed some distance apart. So now we will consider a spherical capacitor. So spherical capacitor. So what is a spherical capacitor? So we'll be having thin spherical cell. One will be the inner one, other will be the outer one. So suppose the radius of the inner spherical cell is here A, of radius A. Similarly, the outer spherical cell, the radius is B. So suppose this is negatively charged, this is your positively charged. So this makes a capacitor. So this is known as a spherical capacitor. So in this spherical capacitor, if we are considering any point, suppose here I am considering the point here. So suppose this point is at a distance of r, at a distance of r. So if we assume this Gaussian surface of radius r from its center O, then we know what will be for a given Gaussian surface, what is the electric field, how to find out the electric field. For Gaussian surface, the electric field can be found out, that we already know from the flux. So flux is equal to 1 upon epsilon naught times the charge enclosed by the surface. So in this case the charge is suppose q, so this will be q upon epsilon naught. Similarly, the flux we can find out by the surface integral of electric field intensity. So this will be equal to E into 4 pi r square. So by equating these two, we can find out the electric field. So this is E into 4 pi r square. So this will be equal to q upon epsilon naught. So in this case here E will be equal to q upon 4 pi epsilon naught r square. So this is the electric field intensity at any point inside the point, inside that this spherical cell, suppose of radius r. So this is E here. So I can find out the V also in this case. So what will be your V? We know the relationship between electric field and electric potential. We know the electric field intensity is the negative potential gradient, or the electric potential will be the negative of line integral of electric field intensity. So in this case, your V will be equal to, this is line integral of negative E dot dr. So now you can see here, this is positive negative, so direction of the electric field will be in this direction, and the R is increasing from O to outer surface. So here we can say the angle between E and dr will be 180 degree, right? So now, so if we are putting the value of E here and integrate, then this will come as minus E means q upon 4 pi epsilon naught r square dr. This will be cos 180. So cos 180, you know, that is minus 1. So minus minus plus. So we can take outside q upon 4 pi epsilon naught. So the integrating term will be r square dr. And here we can put the limits. This radius is varying from surface of the inner spherical cell to the surface of the outer spherical cell. So we can write here, this will vary from A to B, from A to B. So similarly, the limits we can use. Now you know what is the integration of r square. So r square dr, that integration of x to the power n dx. So this will be x to the power n plus 1 by n plus 1. Here r square is in denominator, so this will be r to the power minus 2. So here this will be r to the power minus 2. So this is r to the power minus 2 plus 1 by minus 2 plus 1. So this will come as r to the power minus 1 by minus 1. So this will come as minus 1 by r, minus 1 by r. ठीक है. So now after integration what will get? This will be q upon 4 pi epsilon naught. This is r to the power minus 2 dr. So this will come as minus 1 by r. Limits will be a to b. So after evaluating, what we will get here? We will be getting this one as q upon, so v is equal to q upon 4 pi epsilon naught. We will put the upper limit first. So this will be minus 1 by b, then minus, then this will be minus 1 by a, the lower limit. So this will come as q upon 4 pi epsilon naught. This will be your 1 by a minus 1 by b. So by taking the LCM as AB, here we'll get B minus A. So this will be Q upon 4 pi epsilon naught. So this is the derivation for the electric potential due to at any point, suppose, so the total electric potential will be V is equal to Q upon 4 pi epsilon naught V minus A by AB. So now how to find out the capacitance? The capacitance will be, you know, Q by V. Q by V. So we'll be using that formula. So your capacitance C will be equal to, capacitance your C will be equal to Q upon V. So this will be Q upon, in place of V we can use this one. So this will be Q by 4 pi epsilon naught. This is B minus A by AB. So here this will come as QQ cancels out. So this will go to the denominator and numerator will be interchanged. So 4 pi epsilon naught, this will be your AB upon B minus A. So this is the derivation for the capacitance of a spherical conductor. So I think it is understood to you all. Thank you.